Hi. So we will start with a new chapter from today's lecture, and which is the drugs acting on the RAS. RAS stands for renin-angiotensin system. Some people also say it as double RAAS, which is renin-angiotensin-aldosterone system. So that's one and the same thing. So to understand first what drugs are going to act on the RAS, we should know about the RAS first, right? So what is RAS all about? And then we can do the drugs which act on this RAS. So here is a small, depiction of what is R. R means renin kya hai, angiotensin kya hai, and what are they going to do in our body. So let's get started, right? So see, this is a nephron, right? So this is a nephron, and this is the the glomerular apparatus, and the PCTs and everything, and this is the afferent arteriole through which the renal blood comes, and this is where it exits, and this is through which the plasma is going to get filtered, all this whatever the waste material or the various solutes and everything, all they're going to get filtered through this and enter into the glomerulus, and then the process of the tubular reabsorption, secretion and everything takes place, and ultimately urine is formed. Now what is the role of renin here, and what does it, from where it is actually secreted? So see, renin is secreted from the juxtaglomerular cells of the kidney. Now what are these here? See, this is, if you see, this is the afferent arteriole here, and the renal blood, the blood is coming through this. Now there are certain cells which are present here. These are endothelial cells, and there are some specialized cells which are present, and they're basically going to sense the the blood flow. If there is a decrease in the blood flow, then they are going to sense it, and they're going to send a signal into the nephron, and that is going to release your renin, right? So these are specialized baroreceptor cells which are present here in the afferent arterioles. Then when the urine is moving here, and when it comes to this part, which is the distal convoluted tubule, there are another group of specialized cells, and these specialized cells, basically they are going to sense the sodium levels. So whenever there is increased sodium is being excreted, or there is deficiency in the sodium, when zyada excrete ho raha hai bahar, so it senses that there is a decreased sodium in the body, and this again sends a stimulus to release the renin. ठीक है? So अब ये जो होता है, because I've shown it a little distant, यहाँ पे distance मैंने ज़्यादा दिखाया है between these afferent arteriole and DCT, but actually में they are present in close proximity, and इसके बीच में there are so many other mesangial cells and other cells are present, right? And JG cells are present here, right? And this whole combination, this pura ka pura system, this is called as the JG apparatus, juxtaglomerular apparatus, which comprises of so many different types of cells. So special baroreceptor cells hai. Then we have this is the macula densa. Okay? So because they are dense looking cells, that's why they call the macula densa cells. And then we have certain cells in between. These are very mesangials and other juxtaglomerular cells. And yahan pe, through this, into these cells, yahan pe kahin se, this renin is going to be released into the circulation. So renin will be released in circulation. So renin kaise release ho raha hai into the circulation? So what is the trigger for release of renin? So number one is when there is decrease in the renal blood flow. So see what happens, let's say a patient has heart failure, congestive heart failure है patient का. So obviously जब heart fail हो गया, congestive heart failure में there is decrease in the cardiac output. जब cardiac output is decreased, so blood flow to all the organs are going to be decreased. So blood flow to the kidneys also going to be decreased. So जब blood flow to the kidney is going to be less, so यहाँ पे these cells are going to sense it. ये वाले cells हैं baroreceptor cells, वो sense करेंगे that decrease the renal blood flow, and they will send a signal to these JG cells to release renin. So renin is released if there is decrease in the renal blood flow, because it can be due to the congestive heart failure, or let's say a person is losing some injury to the person, बहुत ज़्यादा injury होगी, patient has an accident, there is an injury to the person, there's a lot of blood loss, ठीक है, blood loss हो गया, so patient obviously इतना blood loss हो रहा है, so blood flow in all the organs are going to be less, so again the blood flow is going to be less in the kidneys, so again these baroreceptors are going to sense it, and what are they going to do? They are going to stimulate the release of renin from the JD cells. So this is that first trigger. मतलब what stimulus leads to increase in the renin, which is the decrease in the renal blood flow. The second stimulus for release is, as I told you, decrease in the sodium ions. ठीक है? So deficiency of sodium, decrease in the sodium ions when there is so much loss from the body of sodium, maybe because of diuretics or anything. ठीक है? So ये वाले cells will sense it, and again they will send a signal to the renin system. So the renin is again to the JD cells, and they are going to release the renin. That's the second stimulus. The third stimulus, if you remember, we did in the autonomic nervous system, that beta 1 receptors are present on the two various important organs. One is the heart and the other is the JD cells. So when there is a sympathetic stimulation, so let's say in the sympathetic stimulation, JD cells, यहाँ पे beta receptors, so these greens one are the beta receptors. They are the beta 1 receptors. So when there is sympathetic stimulation, the beta 1 receptors, they get stimulated and they cause release of renin. So all these three conditions, they lead to increase in the renin in the circulation, increased renin in the circulation. So this is the importance of renin. So we already have done it in physiology before. You must have done it before. Just to revise, that it is released from the JG cells of the kidneys. And why is it released in the body? Whenever there is decrease in the blood flow because of any reason, whether it's decrease in the blood volume because of the CHF or because of some injury, accident, loss of blood, or there is decreased sodium in the person, the sodium is being lost through some mechanism, especially if it is a diuretic causing loss of sodium, and deficiency of sodium leads to the stimulation of the special types of cells, macula densa, इनका काम ही है sodium को sense करें, and then they will send a signal to renin again. And the third stimulus is when you directly stimulate the beta 1 receptors on the JG cells. So when they are directly stimulated by the catecholamines, what they do is they are going to actually increase the renin secretion from the JG cells. So अभी तक हमने किया कि renin secrete कैसे होता है. अब renin आगे क्या काम करता है, किस लिए काम करता है, that we are going to do now further. So first अभी हम renin पे पहुंचे हैं. We have not come to the angiotensin part yet. ठीक है? So let's only discuss about renin. And so renin or अभी हम we are going to only concentrate on the renin part yet. We have not come to the angiotensin part. We'll come to it in the subsequently later. So first let's see. So see, ये जो renin angiotensin system होता है, ये हमारी body, it's present in the body, and it's mainly there are two types. One is called as the circulating, जो circulating throughout the body, and the other one is called as the local, which is present in certain tissues itself. वो tissues के अंदर ही रहते हैं. They are working in the tissues itself, and this circulating is circulating throughout the body. Now the circulating renin angiotensin system, and that's the main system, and that we are going to do in detail. While the local system is local to certain organs. For example, it is present in the heart, it is present in the kidneys, even it is present in the brain and blood vessels. तो यहाँ पे ये present होते हैं as a local system. ठीक है? अब जो circulating जो RAS होता है basically, that is when you release the renin, जो हमने किया, it is released from the JG cells, and then it further goes and does the work. Now जो renin है secrete, यहाँ पे भी जो renin है, it is secreted locally, it is synthesized locally and secreted. So when renin is formed, बनता कैसे है? It इसका precursor होता है pre-prorenin. It is a precursor for renin. Now it is same whether it is a local or in the circulating. So pre-prorenin is first synthesized, and then it breaks down into two components. One is called as the renin and the other one is called as the prorenin. Similarly here also. So they form renin and prorenin. So initially it was thought that only renin is the active form, prorenin active नहीं है, पर अब देखा गया है कि prorenin is also active. Now what do these do? Let's come to what they do now. Because ultimately what they're going to do is these two are going to act on their receptors and they're going to produce their effect. So ये अपने receptors पे act करेंगे and जो receptor है उसका नाम है prorenin receptor. So both of them will act on this particular receptor PRR and they're going to produce their effects. Now renin is going to how is it activated? It goes and acts on its receptor and it gets activated. It is very simple for renin. But prorenin ke liye there are two mechanisms how it gets activated. So let's do this. Prorenin gets activated by two ways. One is with the help of an enzyme. One way is it can get activated with the help of an enzyme. And the second way is it gets activated when it attaches to the prorenin receptor. So this is the enzymatic. First let's do the enzymatic activation. So there are certain proteases enzymes are present. So this is the structure of a prorenin. Now prorenin this is the active site here. Okay? And this is the active site. It is blocked. So यहाँ पे जो active site है इसकी, it is not open to any of the agonists as such. It is blocked. There's a block here, and this block is called a propeptide. So there is a propeptide chain which blocks this active site. So it is not active. तो अगर हमने इसको activate करना है, this propeptide chain needs to be broken. And what helps in breaking of this? There are certain enzymes like proteases and all. There are certain enzymes are present. They will break this. So this will cleave off. The chain is going to break, and this is now visible. This is free. So ये जो पहले इसको cover करा था, it is over. Now this is free. So the agonist can go and attach to the site. So this prorenin, when it becomes activated, it is called as renin. It activates into renin, and renin में ये site is free, and जो substrate होता है for this enzyme is the angiotensinogen. This is the name of the substrate, or the agonist, actually the substrate basically, which because it's renin is also an enzyme. Okay, so renin is an enzyme, so it has a substrate angiotensinogen. So angiotensinogen can attach only when there is activation of prorenin with the help of enzyme. So there is breaking of this propeptide chain and exposure, and this becomes renin, and renin is activated. Now this conversion of prorenin to renin by this, because इसमें ये टूट गई है chain, ये वापस जुड़ नहीं सकती. It's broken. It cannot be attached back to जैसे renin में दोबारा लगा दिया prorenin बन गया. No, this is not possible. So therefore this process is irreversible. Okay, conversion by this method is irreversible, because once this is broken, it cannot be attached back. The second method by which it can get activated is by action on the receptors. So this is because there's no enzyme, there is a receptor involved. So इसमें क्या होता है? This prorenin is present, and there is it's the same. Let's assume ये prorenin जिसमें propeptide था, ये receptor पे लग गया. So as soon as it attaches to the receptor, this moves away. It will not detach. जैसे ये यहाँ पे लगा हुआ है receptor के आगे, ये propeptide chain है. It is not going to break like this. It is just going to do like this. So this area is now open, but this chain, propeptide chain, is still attached. ठीक है? So ये जब site खुली है, this is now active site, and it also can bind the angiotensinogen. ठीक है? So जब इसका effect खत्म हो गया, after some time, this chain can again come back, and it can again go back to its previous form. ठीक है? So chain ऐसे हो गई, फिर chain ऐसे हो गई, क्योंकि ये टूटी नहीं है, इसको जोड़ने की जरूरत नहीं है, इसे ऐसे करके खोलिए और फिर बंद कर सकते हैं. So because this is a reversible process, so therefore this becomes a reversible process. So एंजाइम अगर इन्वॉल्व है दैट कॉजेज ब्रेकिंग ऑफ दिस चेन, दैट इज अ रिवर्सिबल प्रोसेस. इरिवर्सिबल प्रोसेस हो गया. और रिवर्सिबल क्या है कि व्हेन इट अटैचेस टू द प्रोरेनिन रिसेप्टर, this thing is going, there's some change, some conformational change or activation of this particular prorenin, so that this will open up, and now this site is open for the angiotensin to come and attach, angiotensinogen to come and attach. And when the effect is over, the time is, it has done its job, it can again go back to its previous site and close it. So again it becomes the non-active or inactive prorenin. So this is a reversible process. Most of the times this is what is happening. It's a reversible process, and this is how it's getting activated. So similarly जो renin है, renin also, renin का simple है, it is only getting activated by this receptor only. So again it has no propeptide everything, only when it attaches here to the receptor it will get activated, and the angiotensinogen can bind to it. So all these mechanism, so prorenin or renin, they both get activated by the receptors, but jo enzyme activation, that's only for prorenin, because that is converting prorenin to renin. So renin to already bana hua hai, again renin won't be activated by the enzyme. So this is how they get activated, and they're going to further perform their actions. So when they bind to the angiotensinogen, they will produce certain effects, which I'll be doing after, in a while I will doing this. And what another important thing about the prorenin that we should know. So prorenin is actually going to do, एक तो इसमें angiotensinogen, it is going to bind this angiotensinogen, ठीक है, and it is going to then do two things. One is it is forming angiotensin 2 dependent pathway, which means angiotensinogen gets converted into angiotensin 1, then angiotensin 2, and there are other effects because of this. The other one is called as angiotensin 2 independent pathway. So there is no angiotensin 2. There are certain other factors that are activated, and they lead to cellular growth, even apoptosis and all those kinds of things. Or jab in certain situations when the renin-angio system is overactive, so and this one, this becomes overactive in tissues, because this is very common in the local RAS. Local RAS becomes overactive. So jin tissues mein this local RAS is present, and this pathway becomes active, it can lead to problems, increased fibrosis, apoptosis, cell growth. So heart mein it can lead to ventricular hypertrophy, kidneys mein it can lead to nephropathies, by chance in the eyes it can lead to retinopathy. So all those problems are because of overactive RAS. So if you want to stop those things, you will have to inhibit this locally acting RAS system. So this is just by the way to tell you that it can act via two mechanisms: angiotensin 2 dependent, angiotensin 2 independent, while renin only has mostly on angiotensin 2 dependent pathway. Right? So let's come to the pathway now, the actual RAS pathway, what happens here. And this is very, very important, because if we understand this pathway, we can easily know the drugs which are going to act on this. Right? So let's start with the first thing here. The first point, what happens? Let's take a different color. The first thing I told you, when there is a decrease, there has to be a stimulus for release of the renin. So let's say there is decrease in the renal blood flow, or there is decrease in sodium, any of the reasons, or there is beta 1 receptor stimulation. Any of these three things can happen. So अगर renal blood flow कम है, this will be stimulated. अगर the sodium है तो macular densa stimulate, B1 receptors खुद से stimulate हो जाता है. It leads to release of renin. So यहाँ पे let's say there is the JG cells present, they are going to release renin into the circulation. So first step is some stimulus which causes release of the renin. Now renin is going into the circulation. This is the whole systemic circulation. And now लिवर से क्या प्रोड्यूस होता है? जो एंजियोटेंसिनोजन की हम अभी बात कर रहे थे, द सबस्ट्रेट, इट इज प्रोड्यूस्ड फ्रॉम द लिवर. ठीक है, सो इट इज प्रोड्यूस्ड फ्रॉम द लिवर एंड इट इज सिक्रेटेड इनटू द सर्कुलेशन. So now what happens under the influence of renin? Renin is required for conversion of this angiotensinogen into angiotensin 1. So this is these angiotensins, basically they are all autocoids, right? And so the first angiotensin 1 is formed from conversion of angiotensinogen to angiotensin 1 with the help of, so renin. Agar renin nahi hoga, then angiotensinogen is not going to be converted into angiotensin 1. So now it is circulating, it enters into the pulmonary circulation. Now lungs mein kya hota hai? So this is the third step. There is release of angiotensinogen 4th, and then there is conversion of angiotensinogen to angiotensin 1. That is the fourth step. Now it enters into the pulmonary circulation, and lungs mein there is an enzyme present which is called as ACE. ACE stands for angiotensin converting enzyme. Okay? It is angiotensin converting enzyme. It's called ACE. So ACE is released from the lungs. Let's say this is number 5. ACE is released from lungs, and what is the role of this ACE enzyme? It converts angiotensin 1 into angiotensin 2. So this is the number 6th release, and then its action. Action is conversion of angiotensin 1 to angiotensin 2. Now angiotensin 2 is very potent autocoid out of all these. There are angiotensin 3B and 4B, and ultimately gets inactivated 1 and all. Out of all these, angiotensin 2 is the most potent and most active, right? So and we are going to do the effect. So before I go into the individual effects of angiotensin 2, let's see what happens further, because it has got a very short half-life. थोड़ी सी half-life में ही ये अपने actions करेगा. But then what happens? It gets converted into angiotensin. 7th would be actually all its effects, let's say, and 8th would be conversion into angiotensin 3. And then it further gets converted. There are other enzymes present which converts into angiotensin 4. Ultimately it gets inactivated. Okay? So this is the whole cycle of the renin-angiotensin system. Now most important यहाँ पे अब क्या है? The effects of angiotensin 2, which are very important. What's the role of angiotensin 2 here? Now angiotensin 2 affects all these organs which I have drawn here, right? So first organ is, it affects the central nervous system. So when it affects the central nervous system, one we can say what it does is that it is going to stimulate the sympathetic nervous system. It's also going to stimulate the antidiuretic hormone. Okay? So ADH and all this is going to be increased. So that is what is the main role in the central nervous system. On the heart, what it does is, so heart we will understand after we do the blood vessels first. Let's do the blood vessels. So blood vessels में क्या करता है? It's a very potent vasoconstrictor. It's a vasoconstrictor, therefore it can increase the preload on, ठीक है? And it can increase the afterload because such a potent vasoconstrictor. तो ये heart पे effect करेंगे. Preload increase होगा तो there will be increase in the venous return. Okay, there will be increase in the cardiac output, and there will be increase in the systolic blood pressure. Afterload increase hoga, there will be increase in the total peripheral resistance, and there will be increase in the diastolic blood pressure. So overall it is going to cause an increase in the blood pressure, increase BP. That is its effect on the heart. So blood vessels में it is going to cause the vasoconstriction. दोनों चीजें, preload भी afterload भी बढ़ाएगा. Then its effects on the adrenal. It stimulates the adrenal gland and it causes the release of aldosterone. That is very important. This is the release of the aldosterone. And because aldosterone is released, what are its effects now? Aldosterone क्या करेगा? So angiotensin 2 भी और ये aldosterone भी together they are going to now act on the kidney. And the role of aldosterone on the kidney is it acts on its aldosterone receptors and it is going to lead to stimulate the sodium and water retention. It leads to sodium and water retention. That is the importance of this. It will lead to potassium ion loss. It will lead to potassium ion. It can lead to potassium ion loss because of this. Then the other thing is it can lead to decrease in the GFR. Decrease in GFR mostly because of the angiotensin 2 and potassium and water retention. It can lead to, this is because of the aldosterone acting on the aldosterone receptor, and it leads to retention of sodium and water. So again, this condition can aggravate the, if there is, you can say it will aggravate heart failure, right? It can aggravate hypertension because of these two factors. Another very important role of aldosterone has been found to be on the heart is it is said to cause hypertrophy of the cell, ventricular hypertrophy, and it leads to abnormal, हमने कहा था कि ये abnormal cells बनाता है, myocardial cells, and that is known as, it destroys this, you can say the structure of the ventricular, the myocytes. It can lead to ventricular remodeling. It is called as ventricular remodeling. So this is a condition where the heart, जो ventricles है, they are suffering, the structural problems are there. The cells are becoming weak and they're not able to function properly. This is because of the aldosterone. One of the causes for ventricular remodeling is aldosterone secretion. So these are the effects of angiotensin 2 on the body. So when RAS is, so see what happened, RAS release क्यों हुआ था? Because when there is decrease in the renal blood flow, decrease in the blood pressure. So ultimately what is the aim? Is to increase the blood pressure because of the angiotensin 2. So then there was decrease in sodium ion. So renin was released. Aim is to retain the sodium ion. So it caused the sodium and water retention. And beta 1 is sympathetic stimulation. Whenever it will lead to all these effects. So these are the effects of angiotensin 2 on the body. Very, very important to remember. So central nervous system, it will further stimulate the sympathetic nervous system and the ADH, and it has a very important effect on the heart, increases the blood pressure, and because it leads to release of aldosterone from the adrenals, and adrenals में जो aldosterone बनता है, aldosterone का heart पे क्या effect है? It is going to cause ventricular hypertrophy, ventricular remodeling, which is not good at all, and acts on the kidneys. Kidneys पे क्या करेगा? It is going to cause retention of sodium and water because it acts on the aldosterone receptor. Very, very important effect, and it leads to a decrease in the GFR also. And these sodium water retention, देखो अगर patient already hypertensive है and sodium is being retained in that patient, so obviously that is going to aggravate its condition. CHF में already there is a lot of volume overload on the patient. आप अगर ये drug दोगे और volume overload हो रहा है, ठीक है? So again that's going to cause the aggravation of his condition. So this is very important to remember about RAS. So trigger, तो stimulus क्या हुआ? Release of renin. शुरू हुआ ये renin से. रेनिन रिलीज हुआ अगर कोई भी कारण जैसे ब्लड फ्लो कम है या कुछ भी कारण, रेनिन रिलीज हुआ. रेनिन को रास्ते में मिला एंजियोटेंसिनोजन, लिवर ने कहा भाई लो इसको एंड डू योर वर्क, आई एम गिविंग यू एंजियोटेंसिनोजन, डू योर वर्क. रेनिन मिला एंजियोटेंसिनोजन को, उसने एक्टिवेट किया, बनाया एंजियोटेंसिन 1. ठीक है, angiotensin 1 टहलता it goes through the pulmonary circulation. It can't do anything on its own. It has to be converted into much more active form, और उस active form में convert होने के लिए it again needs somebody to help him. And कौन आता है उसकी help करने? ACE enzyme. ACE always means very good. You ace it at, ACE इक्का. तो आया उसके पास, उसने एंजियोटेंसिन 1 को कन्वर्ट किया एंजियोटेंसिन 2 में, and it is a very, very potent or very highly efficient autocoid. Now angiotensin 2 has a wide variety of effects. Now before I go to that, it also then further it has a very short half life. फटाफट metabolize हो जाएगा angiotensin 3, then 4, and then becomes inactivated, right? So angiotensin 2 फटाफट उतने ही छोटे टाइम में इतना काम करता है, acting on the central nervous system, on the heart, on the blood vessels, on the adrenals, right? It has and as well as the kidneys. So all these effects are produced. Its main effects, आपको अगर सबसे important effect इसका याद रखना, that's increase in the blood pressure. It's a potent vasoconstrictor, leads to increase in the blood pressure. That's a very very important point you cannot afford to forget. Increase in the BP. क्योंकि जो बाकी है सोडियम वाटर रिटेंशन इज थ्रू एल्डोस्टेरोन, वो डायरेक्टली नहीं कर रहा, थ्रू एल्डोस्टेरोन कर रहा है, बट remodeling is also through aldosterone, but these are the direct effect. Vasoconstriction is a direct effect. Diffusion, preload, afterload is one of the direct effects. And then so these are the major effects. Now इसमें जो angiotensin 3 है, इसका रोल भी देखा गया है कि its effects are just like angiotensin 2, but it is not as potent or as strong as angiotensin 2, and angiotensin 4 doesn't have many effects. Central nervous system में थोड़ा बहुत effect है, it's not very clear right now, but mostly we are supposed to focus on angiotensin 2, right? So these how now the only thing that we are going to do in the subsequent lecture are how this angiotensin 2 is going to act. So what are the receptors on which it acts, and then we are going to do drugs acting on this whole RAS. Okay, so for today you just go and revise the whole system, because the same diagram I'll be taking up and इसी पे हम drugs भी करेंगे. तो आज के लिए जो सबसे important points है apart from this RAS mechanism is what is renin, और renin कैसे release होता है, कितने types के renin है. So this is just the basic physiology that you should know. From the JD cells release होता है because of those three stimulus, decrease in the renal blood flow, if there is beta 1 stimulation, or there is decrease in sodium concentration. All these lead to rise in the renin. This is the important thing. Types of RAS is circulating, can be local, any type. ठीक है, but ultimately बनना उसमें से renin ही है या pro-renin बनना है. Pro-renin can be activated by two mechanisms. One is by enzymatic conversion into renin, which is an irreversible process, because उसमें जो इसका चेन था वो टूट जाता है, टूट के वो वापस जुड़ नहीं सकता. जो दूसरा reversible process is by acting on the receptor, it gets activated. That is reversible. Why reversible? Because वो सिर्फ ऐसे खुला है, आप गेट खुला है, अगर गेट खुला है उसको बंद करना आसान है, अगर कोई गेट तोड़ ही देता है उसको लगाना तो बहुत मुश्किल है वापस, right? So that's why that is irreversible, and this is a reversible process. And the most important thing in the lecture today is this particular system, because once you know this system, अगर ये system आपको याद रह जाता है, and you know you can draw your diagram, even if you draw with me or you draw on your own, you have this video with you, just draw it in your own hands. And this is a very very interesting diagram, a very important topic also. So many drugs are there जो आजकल देते हैं for hypertension, which is acting on the renin-angiotensin system. Very very important drugs इसमें हैं जो आजकल काफ़ी चलती हैं. So they are going to act on this particular system. So yes, so we meet to next time with another video of receptors, and then we start with the drugs acting on the renin-angiotensin system. So take care till then, revise your topics, do it thoroughly. All the best. Thank you.